As a result of electrolysis, we have seen how the metals are deposited or gases are liberated at the anode or cathode respectively. So based on electrolysis, we have two laws that is called the Faraday's laws of electrolysis. The first law, let's see that. The first law states that the weight of the substance liberated at the electrode as a result of electrolysis is directly proportional to the quantity of electricity passed. So I've shown a small diagram here, the cell. So we have seen the two electrodes are connected to the battery and the cations will be deposited here and the anions will be deposited here. So this deposit, how much it is deposited, it depends on the quantity of electricity passed. So let us take for example the weight, or we can also say mass. So this would be proportional to the quantity of electricity, is nothing but the charge, amount of charge, right? So W is directly proportional to Q, or you can also say mass M is directly proportional to Q. But we know this charge, that is electricity Q, is equal to I into T, where I is the current in amperes and T is the time taken in seconds. Okay, so therefore the W will become or will be directly proportional to I into T. Suppose we want to remove the the proportionality constant, then W will be equal to Z I T, where Z is the electrochemical equivalent. So we can say that the amount of or the mass deposited in the respective electrode is directly proportional to the current into time multiplied by the electrochemical equivalent. So we know the amount of substance deposited in the electrode is equal to, that is W is equal to ZIT, where Z is the electrochemical equivalent. So now let us see what is this electrochemical equivalent. It is the weight of the substance liberated when 1 ampere current is passed through the electrolyte for 1 second. Okay, or we can say Z is equal to equivalent weight by Faraday's constant. So Faraday's constant is nothing but charge on 1 mole of electron, and it has a value F is equal to 96,500 Coulomb. Okay, so now let us see, suppose let us say that in a silver nitrate solution, okay, AgNO3 solution, we pass 1 Faraday of electricity. So then what will be the equivalent weight Z will be equal to, so when we pass 1 Faraday of current, so amount of silver deposited in the electrode will be equal to the weight of the silver. So that is nothing but 108, okay, divided by 1 Faraday. So this is 96,500. So this will have the value 0.0011. Okay, so this will be the electrochemical equivalent of silver. Now let us see the second law. It states that when same quantity of electricity is passed through different electrolyte solutions, the weights of different substances produced at the electrodes are proportional to their equivalent weight. Okay, so now I've just shown you diagrammatically. I've taken 2 cells, okay, connected both of them in series. So in one I have taken the electrolyte as a silver nitrate and other one as copper sulfate. Okay, so now as per the second law, we know that W is directly proportional to Z into Q. Okay, W is equal to Z into Q, right? So now the amount of substance, so let us take in the first electrode, amount of silver deposited will be 108. We know the atomic mass. So W of silver will be equal to, what is Z? E by F, equivalent weight by Faraday, into Q. So this E will be equal to E silver. Similarly, W of the next solution, that is copper sulfate, so Cu will be equal to E of Cu divided by F into Q. Okay, so let us take this as equation 1 and this is equation 2. Then if you divide 1 by 2, so this would be W of Ag divided by W of Cu will be equal to E of equivalent weight of silver divided by equivalent weight of copper. Okay, suppose let us take, like, we know 108 will be the that many grams will be deposited in the silver electrode. So this will be equal to 108. And we know that for copper equivalent weight, because it is 2 plus in solution, so the equivalent weight would be 31.75. So the amount of substance which is deposited will be equal to here 108 grams of silver and 31.75 grams of copper here.